Hi, today I'm going to talk about many material engineering and semiconductor. So let's start. First, let's talk about the high-K metal gate. Nowadays, we make a smaller semiconductor than before, so we should scaling down the lateral side and also the vertical side. So because we want to make a smaller size semiconductor, so we should scaling down like both sides of them. So engineer makes some solution about the gate coupling, scaling down solution like gate coupling because of the scaling down of lateral side, we cannot control the gate very well than before. So we make we should find something gate coupling very well materials. So engineer make a solution about them. So they find a solution for high K. So the dielectric constant is very high. So those material, and there are many material, not so many, but there are many material which have a high dielectric constant. So we make them and then make a higher mobility to carrier. So and then because of the high K material, we can control the gate very well than before. So nowadays we use a high K material to control the gate. And then the interface engineering. This is a very important part of the semiconductor because we should put another material between the layer. So we should make a different layer each layer. So the interface should be made in the material between the materials and materials. So when the interfaces are made, the interface trap like a CIT. It means the capacitance between the interface. So this means this CIT makes bigger than before when the interface trap is higher. Yes, so we should know about the characteristic of interface and how to decrease those interface trap than before is very important topic of the semiconductor engineering. So in this case, we make a channel layer in here, and then the gate dielectric layer in this is the between the two layer. We make a lower interface in here, and then between the gate and the gate electrode, we make a upper interface because if we make a pure material to the something layer like gate electrode layer and then gate dielectric layer, those interface characteristic is not good because the material structure. So we should make a harder bonding to to use those upper interface or lower interface. So yes, this is the one of the method of the interface engineering. Then we should know about the characteristic of interface state, because we always meet interface while we do engineering. So this is the acceptor states and the donor states. So we can divide two states in here, and then there are many traps in here, like this line. So those lines. So everything is gonna be an interface trap, and then this is also the schematic of the interface. So we know about the electron and hole in here. So how many traps are located in the interface? We should know about those value. So if before I said the many interface states make a bigger interface capacitance. So when the capacitance of interface is higher, the subthreshold swing gonna be bigger than before. So but in the semiconductor engineering, we should make a smaller subthreshold swing, because we should make a bigger on-off margin, and also if when the subthreshold swing is big, the semiconductor flows many of current. So we should know about the characteristic of because of the interface states, it makes many serious results, like of subthreshold gonna be bigger, and of current also gonna be bigger, and then because of them the semiconductor cannot switch on off very well, so the power consumption gonna be higher also. So because of the interface trap and states, many results gonna be changed. So we should know about the characteristic of interface and should be engineering very well. So lastly, I will talk about the thermodynamic stability. So yes, this is the drawback. So when the dielectric constant 8 to 10, this is it is big. It is quite big number, but this is the short-term solution for semiconductor engineering. So also the fixed oxide charge at polysilicon and high-K interface, and so because of the thermal energy and temperature, the many characteristics of semiconductor are gonna be changed. So we should, because of for example, when we annealing after the annealing, the semiconductor characteristic, IV characteristic gonna be changed. So like that, the thermodynamic stability is very important topic of the in the semiconductor. So we should know about the problems of the thermal energy, and then we should find some solutions to how we make lower lower thermal energy in the semiconductor engineering. So today I talk about the many material engineering. So thank you for watching my video. Bye.